이사하이 친구들 앞답니다.
안될과학 인터뷰입니다. Hey, nice to meet you. I'm so happy to meet you because I didn't expect I can talk with you about Biosphere 2.
You're welcome, and it's my pleasure as well. So I'm looking forward to this. So my name is John Adams, and I'm deputy director at Biosphere2. Now, I've had the good fortune of working at this facility now for 26 years. Today, as my role as deputy director, it gives me an opportunity to provide oversight and guidance for virtually everything that happens here at Biosphere 2.
I'm really shocked that you worked in there 26 years, right?
26 years, yes.
Oh, so you are the history of Biosphere 2, right?
Well, I'm part of the history. I mean, really,
Biosphere 2 is just started maybe in 1991, right?
That's right. Yes.
It's just 30 years.
Yep. I came in October of 1995.
Wow. I'm talking with the history of Biosphere 2.
Part of the history, yes.
Biosphere 2 is really amazing place. It's phenomenal, right?
Biosphere is such an amazing place because, it was started by a group of people who really had a very ambitious, they were thinking outside the box. They were going to do something that no one had ever attempted to do. And even today, to this point, no one has attempted to duplicate Biosphere 2. For me, when I look back at the original people who built, came up with, and started Biosphere 2, I am just in awe because it works, and it works really well. This idea of a facility like this potentially being something that we could replicate on the moon or Mars for a long-term colony. Now, I've come to realize that we've got a lot that we need to learn before we're going to be able to make that type of a jump. But nonetheless, Biosphere 2 is so critical, whether we're using it to understand Earth systems or whether we're using it to understand how Earth systems could potentially play a role in a moon or Mars colony.
And actually, you already have a bunch of database over 30 years, right, inside Biosphere 2. So are you already doing the tests for the climate change in there? I mean, the increase the CO2 gas inside, and then
we are. We've done a lot of experiments around those themes. That's the key, is that we know that it's getting warmer. We know that it's getting drier. We know that there are gas changes atmospherically, like increasing CO2.
Right.
Biosphere 2 allows us to test these ideas before they actually happen. And we've had some really exciting research come out here recently from Biosphere 2. So not only is the historical research unprecedented and extremely important, but also the research that we're doing today and that we're planning for the future, I think is going to impact all of our lives.
It's crazy. You are also working for our Earth, right?
Yes. And yes, we are. We're working to understand our Earth. I mean, it is so true that, if we're not able to adapt, we're not going to survive, right? We need to understand in many ways what is coming our way, because that makes our adaptation, that makes us changing things much easier to do. We're but one piece to the puzzle.
Can you explain what's the meaning of Biosphere 2 and where is Biosphere 1? Because many Koreans doesn't know about that. So we should introduce about this.
Yeah. So Biosphere 2 was originally built and conceived with this idea of trying to better understand Earth systems and how those systems work together. And so when they came up with the name Biosphere 2, they named it after Biosphere 1. Biosphere 1 is the Earth. It's the place that you and I live.
Yeah.
And what they were trying to do is they were trying to try to create Earth systems partially and capture them inside this facility. And why they named it Biosphere 2? Because they wanted everybody to ask, where is Biosphere 1? And we all have to remember, we are living on Biosphere 1. And Biosphere 1 is so important for you and I, because without it, we would not be here. Without the resources that come from Biosphere 1, we would not be able to live. And so it's extremely important that we understand, that we protect, and we preserve Biosphere 1, because without it, none of us are going to survive.
Okay, that's why they made the name as Biosphere 2. Then how much of the cost was spent to build that Biosphere 2, and who started and funded this amazing place?
Yeah, so the construction for Biosphere 2, they broke ground in 1987. And they completed the structure and the facility in 1991. So it took them 4 years to build.
Okay.
And the estimated cost for building Biosphere 2 is about $250 million. And so that's in late 80s, early 90s dollars. So as you could imagine with inflation today,
Yeah.
it's well over $1 billion. All of those dollars that were necessary, that were needed to build Biosphere 2, those were privately provided by a gentleman by the name of Ed Bass.
Mm-hmm.
So he is very philanthropic. He is very environmentally conscious, and he supported and financed the building of Biosphere 2.
Can you explain what kind of areas are in Biosphere 2 and what is the purpose of each area?
When they built Biosphere 2, again, they recognized that they needed to have conditions that were going to be able to be maintainable given the external environmental conditions. The systems that they would be able to recreate conditions for are those systems that are tropical or subtropical in nature. We have a tropical rainforest, so most of the plants, and it was originally modeled after an area that you'd find in the Amazon basin. Right behind it, as you work your way south in the facility, essentially at ground level, we have the ocean. This was modeled after a Caribbean reef environment. Many of the specimens were collected off the Yucatan Peninsula there in Mexico. It's 2.6 million liters is the volume of it, and its deepest point is just a little bit over 7 meters deep. Now, right up from that, you have the savanna, okay? So a savanna, by definition, is sparsely distributed trees with a grass understory. And at Biosphere 2, that grass understory has slowly gone away because the canopy has closed in and shaded everything below, where that wasn't the original case when they planted it. But as you can imagine, those trees have grown significantly in 30 years. Now, upper savanna is dominated predominantly by acacia trees. It has a stream running through it, a freshwater stream. But if you look over from the upper savanna down, you see the ocean. But then right behind the ocean, you have the mangrove system. So we have mangrove trees that were actually collected from a site that was slated for development in Florida. We have one of the largest indoor mangrove systems anywhere. And some of our mangroves now, have been growing for over 30 years.
Mm-hmm.
And some of their height is upwards of, close to, 15 meters, 18 meters. So they've gotten big. They're tall inside Biosphere 2. So, for example, the rainforest is the tallest point in Biosphere 2. It's 28 meters. And then the tallest point sort of in that mangrove area is going to be about 18, 19 meters. Now, we have trees in the rainforest that have grown all the way to the top.
Oh my God, it's really taller than what I expected.
Yeah, it's big. It's really big. It's hard to imagine the size. I mean, look, it's 1.27 hectares in size is its footprint.
It's really huge. I didn't expect that. I really want to go there.
Oh, you need to visit.
That.
Well, you're going to visit. You're going to
Right,
get a chance to
right.
see it. So, I mean, it's going to be amazing.
I just wonder how's the weather these days all on the Biosphere 2?
Well, so, today, mid to late summer for us,
Uh-huh.
and we get not only rain during the winter months, but we also get rain during the summer. But what's really unique about our summer rains is we call them monsoons. Yesterday, we had a really intense thunderstorm here. So these summer monsoons are extremely important, but they're also very, very unpredictable.
Anyway, Biosphere 2 project is started in 1991 with 8 Biosphereans, right?
Yes.
Yeah, so can you explain to us who were the Biosphereans at the time and what they did in Biosphere 2?
The people who built Biosphere 2 and who lived inside Biosphere 2 or partially helped build Biosphere 2 as an entire team, we call them Biospherians, okay?
Yeah.
And the people who are Biospherians that were originally part of the project, they come from a wide range of disciplines. And backgrounds. They wanted to understand Earth and they wanted to better understand Earth, but they recognized that Earth is so complex that there's no way that we can begin to understand it. And that in order to do so, they needed to simplify it. And in doing so, they came up with the idea of building Biosphere 2. So that even though Biosphere 2 is complex, it's much less complex than the Earth itself, Biosphere 1. So they put together a team. They consulted with scientists and engineers who helped them come up with a design, who helped them build and construct, and then ultimately create what is Biosphere 2 today. And On September, the first 8 Biospherians sealed themselves in Biosphere 2, and they stayed inside for 2 years. So it was 4 men and it was 4 women. And when they were sealed inside Biosphere 2, Biosphere 2 only lost 10% of its volume annually. So Biosphere 2 is 1,000 times more well sealed than your typical skyscraper or building. Its leak rate rivals that of the International Space Station. And so they achieved a remarkable engineering feat. And again, they were solely dependent on their nutritional needs, on their atmospheric or their breathing needs based on the atmosphere and based on the conditions inside Biosphere 2. So the reason that they wanted to have a rainforest and an ocean and a savanna and a mangrove system and a thorn scrub and a desert and a separate area, a separate farm area, was they wanted to have a balance. And they wanted that balance to be there so that the plants would recycle the carbon dioxide that the humans were breathing out, and that the agricultural area would create the food that they needed nutritionally and for their calories because they were working inside. Now, what they quickly realized is that they put in very rich soils in the rainforest and in the farm area to support the intensive growth that these plants were going to initially go through. And so they didn't want the plants to be nutrient deficient. And so in doing so, and in creating this really rich soil, they also created a great environment for microbes. And so no one was really thinking about the microbiome 30 years ago, but it was the microbiome that ultimately played one of the most important and significant roles of Biosphere 2. And that's because what happened is the soils and how organically rich they were, that nutrients and that high level of nutrients supported a very abundant and diverse microbial community. And those microbes consumed oxygen and they gave off CO2. Now, the plants, through photosynthesis, were supposed to take in the CO2, take up a little bit of water, split the water, use the hydrogen, give us the oxygen, and find a balance, right? That didn't happen. So what happened is from the time they closed the door, oxygen started to go down.
Because microbiome just
because the microbiomes,
all the oxygens, and then
they're consuming all the oxygen.
Oh
so the microbiome respiration outpaced the plant photosynthesis. So they didn't have a balance. And so oxygen dropped down to 14.2%. Outside, oxygen at sea level is, right around 21%.
Right. But it was
14.2%. Yes.
Wow.
They had a very difficult time. And part of the 8 people that were living inside Biosphere 2, one of them was a medical doctor. And his name was Ray Wolford. He was a physiologist from the University of UCLA. What he did is he recognized that his ability to remember things, he was starting to have really bad headaches. He was forgetting. He was really tired. And so a lot of that, he believed, was the result of this oxygen going down. Well, once it got to 14.2%, he said, okay, time out. This is getting way too low. This is getting dangerous. We need to do something. So they went into the south lung and they added oxygen into it to be able to bring that level back up that's more suitable for you and I to live. But in doing so, they received a tremendous amounts of criticism because they weren't forthcoming that they were actually going to do that. So they didn't tell anybody except for a very small group of people that they were doing that. And they ended up having to retract some media statements. And when you do those things, it's very difficult to recover. Your reputation is tarnished. Oftentimes what you'll hear, if you go on YouTube and watch videos, or you read old press clippings, or even then, many people refer to that first 2-year mission as a failure, that Biosphere failed. But I'm here to tell you right now, there's no such thing as a failed experiment. The reason we do experiments is we don't know what the outcome's going to be. And again, no one had ever attempted to build anything of this size and of this complexity and to be as hermetically sealed as Biosphere 2 was. That in and of itself is remarkable. But the fact that it works, that it functions, and when you walk inside the Biosphere 2 and you're standing in the rainforest, you feel like you're in the South American jungle.
So why doesn't Biosphere 2 have a plan to start this project again? I mean, we already have database inside Biosphere 2 and we have a bunch of developed technologies these days. So
Right.
maybe I think we can try to do this again. So do you have any plans to do this again?
So we don't have any plans to do that. I know there are others who are talking about it. I would love to see somebody else build a Biosphere 3, for example.
Got it.
Because you're right. We have had, 30 years later, we can look back and say, okay, if we would have done this differently, we could improve on the design. And there are material choices that are more readily available than they were historically. And so there is an entirely new set of parameters, a new set of conditions that could be leveraged to be able to build on the original design of Biosphere 2 so that we can do some of these things. And that's what's really, exciting, but unfortunate that you don't see anybody building a Biosphere 2 3, or if they are, they're talking about building it on the moon or Mars. And I know that's exciting. And a lot of people like to talk about that. But for the overwhelming majority of us, we're not going to be able to travel off our planet. Okay.
Right.
So we better take care of this one, because if we don't, then potentially we're not going to have a place to live and we're not going to have anywhere to go.
Earth is the best planet to live in, right?
Absolutely, it's the best place because no matter how many exoplanets we find, to my knowledge, none of them even come close to having the same conditions that would make our lives possible.
Okay, so can you introduce me one of the main research projects these days in Biosphere 2?
The research that we're doing today is specifically, we just wrapped up an experiment in our rainforest where we subjected it to a 70-day drought. And we looked at how our tropical system, how it cycled carbon, energy, and water as it went from an unstressed, really wet state to a very stressed, very dry state. And there's a lot of researchers who are interested. We had over 13 different institutions that were part of this experiment. We had over 80 or 90 researchers, everybody from senior research folks all the way down to undergraduates helping out. And the first paper was published in Science. Then we've got another paper that was just accepted into Nature. So Nature and Science are two really important journals.
Right.
And we've got I just looked at the list. I just got a list from some of the researchers, but there's probably at least another 30 or 40 papers alone coming out from that experiment. Now, previously, what we've done and some of the experiments I've been involved with, we just had a paper about a year ago come out in Nature Plants, and it was looking at photosynthesis, and it was specifically looking at photosynthesis as the temperature got higher. And a graduate student, what she looked at is she looked at how thermal tolerant were the plants in this area. How did those plants do as that temperature went up from a photosynthetic standpoint? And what they found is that the plants deal with temperature much better than what we originally gave them credit for. So that's what's really exciting. Actually, back to the rainforest. So the rainforest, we did another experiment that was really cool. So CO2 continues to go up in the world's atmosphere, right?
Yeah, right.
So we see CO2 ratcheting it up, and it goes up a bit every single year. Today, CO2 level in the atmosphere is about 411 parts per million. And in 50 years, it's likely going to be 600 parts per million. And in about 100 years, it's going to be 800 parts per million. How are these systems going to behave and respond to this change in atmospheric CO2? So Biosphere 2 in our rainforest, we actually took it through a series of CO2 levels because we wanted to know at what point does the system saturate. And this was really important because there was a paper and there was a research team that predicted that once CO2 got to 600 parts per million, tropical systems like the Biosphere 2 rainforest would stop absorbing CO2.
Because it's saturated.
You're saturated. That's right. But how do you test it? So we actually took our rainforest through a series of CO2 levels, and we too found that our system saturated at 600 parts per million, just like the real rainforest. So what this gives us is the confidence that the models we're using to predict outside, so model validation and calibration is what is so critical with Biosphere 2. Now in our ocean, we've done things where we've changed the water chemistry to simulate atmospheric CO2 concentrations like it is today, like it's going to be tomorrow, and like it's going to be well into the future. And we were one of the first places to show that as CO2 goes up in the atmosphere, because it's a gas that's soluble in water, it's going to change the ocean pH. It's going to make it more acidic. That reduction in pH, we typically hear today as ocean acidification. But what also is happening is CO2 is combining with water to become carbonic acid. And carbonic acid then actually reacts with a bicarbonate ion in the water column to become two bicarbonate molecules. This bicarbonate form is no longer uptakeable by things that calcify. And so what we found is that higher CO2 means slower and slower coral growth, which is really detrimental. The final area that I'm going to talk about is called LEO, the Landscape Evolution Observatory. Now, this space looks very different. It includes 3 artificial landscapes that were constructed inside the former farm area of Biosphere 2. You know, each slope consists of about 1 million pounds of loamy sand basalt, so like a volcanic material. They're about 3.3 feet deep. It's on a 10 degree slope. What we're doing in there is the premise of the experiments is it rains in the mountains. How much water ends up downstream for you and I to use, and what impacts the quality of it? How the gradual evolution, how the change in this landscape changes the dynamics of the water cycle. And what we've done is we pulled apart the physical and the biological worlds, because right now we don't have any plants on it and we're just studying it in this state. But actually next year at about this time, we hope to be adding plants onto the slope. And so we're going to look at, when you add biology in, how does that change the dynamics of the slope itself? How does it change what's happening to the watershed? And so that's another thing that you just can't do outside. And so Biosphere 2 gives us insights into some of these fundamental mechanisms and processes in ways that we can't get anywhere else in the world. And that's why it's so critical as a research tool.
Actually, I didn't expect that kinds of different type and huge experiment inside the Biosphere 2. So now I have one more question. So if some scientist in South Korea wants to co-work with Biosphere 2, then how can they contact with you?
That's a great question. So Biosphere 2 is owned and operated by the University of Arizona today. But we think of Biosphere 2 as a user facility. We want people from around the world to come and use this unique asset, because we know that there are many researchers who have brilliant ideas that we didn't even think of that could really leverage Biosphere 2. And so what we've done is we've set up a science advisory group. So we've got a group of senior researchers, and they help to evaluate, you know, all different types of research protocols and ideas for Biosphere 2. And you can go right to Biosphere 2's website. You can go to the research tab, and then underneath that research tab, if you've got an idea that you would like to do at Biosphere 2 and you have the funding to run your experiment to do so, you can actually submit an idea and a concept to us, of which it will, you know, then that will open up a dialogue, and we can look at what's the feasibility of actually doing something like inside Biosphere 2, and then what resources are needed to realize it. So the Rainforest drought experiment, we have folks from Germany and Austria and Switzerland and England. We have collaborators in Australia and in Mexico. So we have people from around the world that we're working with.
But there's no South Korea.
To my knowledge, I don't know of anybody from South Korea.
So sad. It's so sad. Maybe, because most of South Korea didn't know that. 보셨죠, 과학자분들? 어떤 아이디어든 갖고 계신 게 있으시면은 언제든 바이오스피어2 홈페이지 들어가셔서 리서치 아이디어들 등록하시고 같이 좀 연구할 수 있는 그런 계기가 되셨으면 좋겠습니다. 예. I'm sorry. I finished it. I finished it.
No, that's fine. That's great.
Yeah.
We welcome that. We look for international collaborations. I mean, obviously everything has to come together, but the first thing is to put forward an idea to see whether it's possible to do inside Biosphere 2 and it fits within what we're doing. But, you know, we'd love to have that question. We'd love to have that dialogue.
Thanks so much. You know, I really didn't expect that kinds of experiment these days inside Biosphere 2. I think I should split 2 videos for this interview. I didn't expect these kinds of bunch of information about that. Thank you for this interview.
No, you're welcome. Yeah. Thank you. Good luck with everything. Safe travels. And hopefully one day we'll have an opportunity to meet.
Okay, I really hope so. So maybe I think I should visit Biosphere 2 one more time to meet you.
that would be great. Yeah, unfortunately, I'm just going to be out and I won't be around. But my pleasure. Have a good day. Bye-bye.
Have a good day too.
와, 저기 보세요.
이렇게 가까이서 바이오스피어2를 볼 수 있을 거라고는 제가 상상을 못했습니다. 여기 갑자기 해변이 펼쳐졌어요.
아, 재밌네요. 이런 연구 실제로 이렇게 이루어지는 거를 본 적이 없어요. 너무 재밌다.
As the air escapes, it's just like it would have done at night. And as 20 tons is falling, it's pushing this air out this door. And you see the waterfall?
Yeah, over there.
Up at the top up there, we have a pond. It's an amazing place.
Yeah.